Hello, everybody. My name is Colby Tresness. I am a PM on the Azure Functions team, and today I am going to talk to you about serverless computing in Azure. So let's begin with the story. My story is the evolution of application platform. Before I talk to you about serverless, I want to discuss some history about how apps have been built throughout the years and how that has led us to the computing options that we have today. Back in the day, you had to do many, many more things than you have to do now. You had to buy your own hardware and software. You had to run it in your own data centers, deal with many, many questions, and really just do a lot of infrastructure things that now you don't even have to think about. So you had to answer questions like, what size server should I buy? How many servers do I need? Who has physical access to my servers? How do I deploy code? Which OS should I use? Essentially just a lot of questions, and all of the answers to these aren't necessarily related to running your core business. So for example, if you're running an insurance company, you want to spend your time growing and innovating in the insurance domain, not worrying about how to actually handle your servers. So along came the cloud, and some of these questions were answered. IaaS, which is infrastructure as a service, allowed you to forget about managing all of that physical hardware. A cloud vendor now hosted servers for you, and you just dealt with the cloud vendor, got your VMs, and kind of did anything that you wanted to do. But there are still a number of questions that you had to think about, like how many VMs do I need? How would my application scale in the future if my usage grows? How do I handle updating those servers? How do I think about deploying code with various dependencies? Who monitors my application? And so on. Basically, it means that you still haven't reached the ideal state where you can focus purely on your business and its problems. So next along the path is platform as a service. And with this, it was even one level further of abstraction and simplification. So PaaS allows you to worry about just your app and let the cloud vendor take care of not only the physical hardware, but also the ongoing management of the operating system, virtual machines, containers, really anything. And you can figure out, the application figures out for you all of the application runtimes, whether it's Java, .NET, Node, really everything. You're not completely free about thinking about servers, though, because you still have to worry about how to scale your application and figure out how many resources you need. So Azure has a really strong PaaS offering, App Service, and I'll demo an application built on App Service later in this presentation. And so finally, we have the latest evolution in this path, serverless, which further abstracts the underlying infrastructure from you and allows you to focus only on one question. How are you going to build your application to achieve the best results for your business without worrying about any of the underlying infrastructure? Whether it's coded to let your customers through a great experience or the logic to communicate securely with a business partner, this is where most organizations want to spend their time and creative energy. Serverless allows you to do just that, focus on your code and forget about the infrastructure. And this is why we believe it's the platform for the next generation of applications. What is serverless? Now, serverless is defined in a couple ways, but first and foremost, it's the abstraction of servers. Now, notice I didn't say elimination of servers. There are still servers present. It's still under the covers somewhere. We are dealing with the servers, we're managing your infrastructure for you, but you as the user don't need to worry about it and can focus on just your business applications. Next, we have event-driven scale. And what this means is that your code happens when it needs to happen. So it will scale automatically if you get large load. It will really just provision the resources that are necessary and nothing else. Additionally, sub-second billing. Because this happens when you need it, because all of the resources aren't provisioned immediately, you can really only pay for what you use. And this happens at the sub-second scale. So if you use one application for one execution for 10 milliseconds, you're billed for just that. So what are some of the benefits of serverless? Now, I've mentioned this a couple times at this point, but the main thing is that you don't have to worry about any of the physical infrastructure. You don't have to worry about any of the cloud infrastructure. You really just focus on your business logic. You focus on solving the problem that's central to your business, and we manage all of the infrastructure for you. And we take care of updates, we take care of scaling, really let you focus on innovation. And this lower effort to get started makes it easier to experiment. Now, the concept I want to talk about is that of a platform, not the individual service. So this is a collection of fully managed services that come together to allow you to build serverless applications. And when we talk about serverless, the first thing that comes to mind is functions as a service. So functions is really kind of the core cornerstone of the serverless platform in Azure. And what functions allows you to do is execute custom code on demand without having to worry about where that code is executing. So it's just a small snippet of code that executes when and where and how frequently and with however much scale you need. And I'll go into some more details later, but that's the basic thing to remember. Functions is a small bit of code. Next, we have Logic Apps. Logic Apps was actually created before functions, which not that many people know. But this service is also a really important part of our serverless story. So imagine you're drawing a flowchart that represents a certain process in your business, say a new CRM, customer relationship management system. And let's say maybe you have, maybe not CRM, maybe you have a new employee. And so whenever that CRM event happens in your CRM software, you could create a project in a project management system which sends an email to 3 other people to do some sort of administrative tasks, adds them to payroll, gets them credentials, something like that. We have processes like this all of the time in business. What if you could convert those flowcharts with just a few clicks of your mouth into a real application that actually does those things? So that's what Logic Apps does. Through a visual design experience, you can create workflows that have multiple steps, and each step can be performed by a different first-party or third-party service, or even you could call a function. You don't need to write code with Logic Apps, but you could if you wanted to. And it goes without saying that you don't have to worry about a server. You don't have to worry about VMs, containers, anything else. You can focus on the what, not the how. And in this way, the experience is not only serverless, but from a user's perspective, it's often codeless, as I mentioned. Now, Event Grid. Whether it's IoT devices sending signals to a central location, users performing some actions on their mobile apps, or even some systems communicating with each other, modern cloud applications are event-driven. But how do we manage all of these events? That's where Event Grid comes in. The service makes it super easy by providing a single, simple interface for managing all of your events. What this means is you can have management of both where the events are coming from, whether it's storage change, a database change, a resource being provisioned, or a new user being added to your subscription. And also you can manage where these events are headed to, whether you need to evoke an Azure function or a Logic app to respond to this event, or even some other destinations. And we believe that for modern applications, an event is important enough that it should be a first-party citizen in Azure. And this takes away the burden of having to manage events without any of the central management tools. So this is what Event Grid does, and it does it very well. So next, we have the basic building blocks of serverless computing in place. What do we want to do next? We are building applications, after all, and applications don't exist in a vacuum. Applications talk to databases. They enable authentication for their users. If it's IoT, it sends and receives data. Maybe they need to process that data and prepare it for further analysis. And more applications are required to have some kind of intelligence in them. So how do we achieve these things? It wouldn't be fun if our application code was running in a serverless environment, but we still had to manage an army of virtual machines to perform these other tasks. And this is what Azure provides us. We have Cosmos DB, a globally distributed elastic-scale database, a perfect ally for your serverless apps. We have Azure AADB2C for your security and access control needs, IoT Hub for your IoT needs. You have services like Event Hubs and Stream Analytics to ingest and event real-time streaming data. And lastly, we have the Microsoft Cognitive Services API to provide intelligence for your apps. All of these services together comprise the Azure Serverless Application Platform. Using these pieces, you can compose your applications. But we have a platform now. So what about the process of building these applications? What does the developer experience look like? I think a really good example of Microsoft's opinion on developer experience is quantum computing. Back in November or so, it was announced that even though quantum computing is in the works and hasn't arrived yet, the programming language and the Visual Studio experience are already here. If there's one thing we do right at Microsoft, it's the developer experience. Even in the cloud world, we provide really great support for developers writing applications. For serverless apps, we provide full end-to-end development experience through tools like Visual Studio and VS Code. We support many features like the ability to build, test, debug your applications locally on your dev machines, even before deploying them to the cloud. Now, this is a massive productivity boost while building cloud applications and something no other cloud vendor can match. All of these technologies support continuous deployment, so you can easily integrate them into your existing deployment pipelines. And finally, we provide full monitoring support through Azure Application Insights to monitor your application in production. So this kind of completes our serverless application platform, and it's really a comprehensive platform. So what kind of scenarios can be built with serverless technologies? This isn't really a trick question, and I've already given you much of the answer. Anything that needs to run some sort of code or logic in response to an event. You'll notice this is a very broad definition, and it covers many, many scenarios. So let's provide some examples. First, real-time stream processing. So IoT devices sending data that needs to be analyzed, enriched, or archived somewhere. This is really done very well with serverless functions, which can be spun up on demand because you don't know where the data is coming and you don't know how much data you're going to get. So you don't necessarily want to build a dedicated infrastructure for peak capacity. Next, almost every organization needs to run some regular task, like deduplication of a database or collecting logs at the end of every week. These tasks that need to be run only at specific times and only for a few seconds don't call for dedicated infrastructure and are best left for serverless solutions. Next, we have building backends for your mobile, IoT, or even web apps. That's a really popular use case since you don't have to worry about backend if you're a front-end developer. In this diagram, you see a mobile app sending an image to a function which stores it in Azure storage. This action triggers another function which creates multiple thumbnails out of the original image. I'll come back to this example later in the presentation. And being able to perform these actions in a serverless manner takes away the burden for the mobile developer having to worry about their backend. And lastly, bots are kind of lately all of the rage. Automated response systems receiving customer events are inherently unpredictable. Building intelligent bots for these scenarios requires a serverless architecture because it doesn't require, but it's a great example of a good fit with serverless because we don't know when people are going to call out to a bot, and a dedicated infrastructure wouldn't necessarily make sense. So these are only some of the many examples that fit well with serverless, but I hope that gives you a good idea of where to start. Now let's move into a little more detailed about some of the capabilities of the core services in our serverless platform, starting with Azure Functions. I like this animation. Functions is in many ways the cornerstone of the serverless platform on Azure. The ability to write custom code to perform your business logic without thinking about the infrastructure is super powerful. And specifically, I'd like to highlight some features about functions that makes it special. And as I was mentioning before, we have world-class developer tooling. You'll see more of this in a minute when I go through my demonstration, but the developer tooling is top of the line. Next, our programming model. Our programming model consists of triggers and bindings, and it makes it really easy to set up event-driven architectures that simplify communication with data sources. We think our programming model is one of our differentiators. Thirdly, we support a number of programming languages. In Functions right now, we have 3 generally available languages: C#, F#, and Node, JavaScript, and many more are coming on the way. We're actively working on this. Lastly, functions support concepts such as continuous deployment, which makes it really easy to integrate with your existing DevOps pipelines. So, just to get back to the triggers and bindings that I mentioned earlier, these triggers and bindings facilitate easy communication with other services. This chart shows us the triggers and bindings currently supported. And as you can see, there are a number of Azure services supported here: storage, database, messaging, notifications, so on and so forth. In addition to those, functions can also support generic HTTP triggers, which means you can easily write a piece of code that can be used to respond to REST API requests or requests from any service that supports webhooks. This also provides a really fast and easy mechanism for building extensions to SaaS applications. And now I will start a demonstration of functions. And I like to call this demo Functions 4 Ways because I'm going to show you 4 separate ways that you can get up and running with functions very, very easily and quickly. So if I go into my Azure portal, we will see way to code a function number 1. So I have here pre-provisioned this function app called Kotresny Demo. That's my alias, my Microsoft internal ID. Very exciting. And this is a snapshot of the Azure portal. The code name of the Azure portal is Ibiza. It's a nice code name, I think. And you can see here, this is the function app. So function app level is the kind of management plane, and it is the container in which you can code your functions. So I have here pre-provisioned this function app with no functions in it, as we can see by this arrow not dropping down anything. So what I'm going to do now is create my first function. And I'm going to do this webhook example using C#, and I will create this function. Now what's happening right now is it's provisioning this function for me. It's saying, oh, I need to go get this file, and starting up my code. It doesn't actually run the code, but it shows me the code which means the application is warm. So let's just walk through what this function is doing. First, we have up at the top the method header. We have our HTTP request, and we are responding with an HTTP response. Pretty simple stuff. And what we are doing now is going through, grabbing the query parameters of our request, and basically we are setting the response to either please pass a name or query string or say hello. So one of the cool things about functions is that you can first test it while you are coding it in the portal. So let's say run, and this aspect ratio is a little funky, but over here we have the sample that's being sent, name Azure, and we can see in our logs we got as output a 200 OK with hello Azure. But I want to prove to you that this is actually working, so let's call this. This is now a live on the internet application, and I can just bump out to this URL and click enter. So we get please pass a name or query string in the request body. So it's really cool that that was actually live, but that's no fun. Let's add a query parameter and say, and name equals, caps lock, name equals Tech Summit. Hello, Tech Summit. Woo, success. So going back to the Azure portal, just to prove to you that this is live and actually responsive to my requests, I'm going to change this code, hello to blank. I'm going to click save, and I'm going to rerun this. And just like that, live in our application, hello to Tech Summit. So this is really powerful. That was incredibly fast. That is a live application, and that has just processed a code change, and it is completely live in my production app, which is super, super powerful. So that's way number one, functions from the portal. The thing about that, though, is that we found that most people who are serious developers don't want to spend all of their time in their browser writing code. So we have a robust set of local development tools that help you get started with serverless. So let's move over to my PowerShell, and I will just navigate to my demos folder, and we're going to serverless Tech Summit. So we have CLI. I'm going to do the CLI first. I have these little folders provisioned for my next three. You get a sneak peek of what's coming next. And what I'm going to do, see, I've proved to you that this is a blank file, a blank folder, and I'm going to do func init. So this is using the Azure Functions core tools. The Functions core tools essentially wrap up the functions host and put it on your local machine, so you can get functions up and running locally. And what's really cool is that the latest version of the functions runtime, the Functions Runtime 2.0, is ported to .NET Core. And what that means is that you can run this locally on a Mac, on a Linux machine, even on Windows, of course. And I think that's really, really powerful. So it's important to call out, I'm not actually using that right here. I have my Windows laptop, but this same demonstration could be completely possible on a Mac. So I ran func init right here. What func init does is it creates that function app. The function app, as I mentioned, is the container in which you put all of your functions. It's the logical grouping of functions. So next, I'm going to type func new. And what this does is it actually starts up my function. I'm going to choose C#, because why not? And I will do an HTTP triggered function. What is my function name? Let's call this HTTP CLI. So I have written those files. Now, just to prove to you that they're there, we will go into this HTTP CLI folder, and look, we've got our files just there. And run.csx is actually what is running the function. So go back up one level, and we have everything as we want it. So now we will type func host start and see our beautiful ASCII art, the Azure Functions logo, one of my favorite parts of the Functions CLI. And what this is doing is getting the functions host up and running on the machine. It's loading some custom extensions because this is the first time I've run this. And here we are. We have this endpoint. So I'm going to copy that, bump back out to my browser, and type that. Beautiful. Please pass a name on the query string. So as we can see, if we bump back to here, we have received a request. It has successfully executed. And to prove, we will add a query parameter just because name equals Colby. Hello, Colby. Beautiful. All right, so that's way number two. So I'm going to kill this. So now I've shown you, one, Azure Functions in a portal, in the Azure portal. 2, Azure Functions locally via CLI. And 3, I'm going to show you VS Code. Now, I mentioned before with the CLI that the CLI is completely cross-platform in the 2.0 functions runtime. The cool thing about Visual Studio Code is that it's inherently cross-platform. So everything that you are seeing could be done just as easily on a Mac. So I've opened this sample VS Code folder. Let's close this here. And VS Code has a nice Azure Functions extension. So all I've done is loaded the Azure Functions extension, and then this just works. So let's do Control-Shift-P to let my little command prompt pop up. And I'm going to do Azure Functions create new project. So what this is doing is very similar to the func-init command that I ran before. This is creating the function app. So I will use this VS Code. Let's just pick the very typical settings for the sake of the demonstration. And here we have our host JSON, local settings, all of our function app level details. Now what we'll do is actually add a function to that, and we will go to the VS Code folder with an HTTP trigger, and I will call this HTTP trigger VS Code. That's the namespace. Let's make it anonymous for the sake of the demonstration. And there we go. So as we can see, this HTTP trigger VS Code comes up here. And this is our code. It is very similar to the code I showed you in the portal. The only thing is that this is a precompiled C#. It's a C# class library function rather than C# script. If you're curious about that distinction, we have really great documentation online that explains this very well. So what I'm going to do now is attach my debugger to this. So let's say I am, before I even run it, I'm in the process of coding locally, and I'm really not sure what's happening in this line. So let's add in a breakpoint. So I'm going to start up my debugger. What this is going to do is, first it's going to do a restore just to resolve any dependencies, so it does .NET build. And after that, that'll take a second or two. We will see that it is actually running behind the scenes func host start, which was the same command that you remember that I ran to get the functions core tools up and running. So this is completed, just a few seconds, and this will only happen the first time you run also. So now the functions core tools is starting up. And here we have our build succeeded and func host start, as I mentioned before. So our beautiful ASCII art, debug console is out here, but we have our ASCII art and it's up and running. So as I mentioned, I'm not really sure what's happening on this line. Oh, and there's my nice endpoint that I can get to. I'm not really sure what's happening here. I'm going to right-click, add breakpoint. So I'll restart this debugger just to make sure the breakpoint picks up. And so that's already up and running. The functions core tools is doing its thing. And I've got this endpoint here. So I'm going to copy here. I'm going to now bump out to this new endpoint, HTTP trigger VS Code, and name equals TechSummit2. Beautiful. So look at that. We have a notification. This is flashing. And look, we've stopped locally in our code on our machine. And I think this is a really good example because Visual Studio Code just shows you all of the great things about your request. You can get local variables. You can do all of your great debugging techniques. So we can see our request URI over here. So we've got this is the absolute path that we're hitting. We can even get our query parameter down here, name equals TechSummit2. And yeah, it's beautiful. Now we press continue, and our function executes our response. Go back to our port or our browser, and we see hello TechSummit2. So that's way number 3, Azure Functions through VS Code. Now let's cut this debugger, close VS Code, and bump out to Visual Studio, way number 4. So what I'm going to do here is create a new project. Visual Studio, similar to Visual Studio Code, has an Azure Functions extension. It's very easy to download. You just search when you are downloading your application or when you're installing VS for the first time. If you download the Microsoft Cloud tools, you will get Azure Functions with it. But as you can see, it's a first-class citizen right inside Visual Studio, which is incredibly cool. You can build and publish your cloud applications without ever leaving Visual Studio. So let's just call this one Function App 1, and I'm going to put this in the VS folder of Serverless Tech Summit. Continue. There we go. So it is now making a template. So let's just do an HTTP trigger, as I've been doing, and make this anonymous. Creating my function app. This is the very simple func-init command that is getting the function app ready, but also this goes and creates my first function for me. Very similar to what we saw in VS Code is this application here. It's an HTTP trigger, and you can do really whatever you want with this. So what I'm going to do is, again, start the debugger. So behind the scenes, this is running the Azure Functions core tools, and this will actually bump out to a new command window that shows, again, my lovely ASCII art, and will start the core tools running and reading any changes. So that's all well and good. We have that up and running. Amazing. Let's say, oh, I'm not really sure what's happening in this line. So let's add a breakpoint. And I will do the same build or debug. Start debugging. I have my breakpoint. This gets up and running. And we have our endpoint. Localhost 771. Copied, pasted here. And let's say, and name equals hello. So automatically bumps back to Visual Studio. We have name is null because I haven't yet set the name. That's what this line is doing. And it's just works. So I press continue. We get our response and hello, hello. And that is Visual Studio, our fourth way of creating an Azure function. So that was 4 separate ways of creating an Azure function in probably less than 10 minutes. It was very, very easy to get up and running. And I think it's a good example of how creating cloud applications is made incredibly easy by the Azure Serverless platform. And that's an important thing to note. There were no servers. You did not have to worry about any infrastructure when you were creating these applications. If I had 1,000 requests to this HTTP endpoint a second, not this one because it's on my local host and I haven't pushed it to cloud yet, but let's say the one that was live via the portal. If I had many, many people requesting that same endpoint at the same time, it would have just worked. It would have scaled out automatically. You would have been billed for what you used based on those executions, and it would have responded to the bursty load and then scaled down when you didn't need it. And that inherently is very powerful. We have Logic Apps. So Logic Apps is a service that provides a visual design experience for creating serverless workflows in the cloud without writing any code. You can write code. Logic Apps is actually just backed by JSON, and I'll show that in a minute, but you don't have to write code, which is actually really powerful for people who don't necessarily have that coding background. So no matter how complex your business logic is, you can express it using the powerful control flow logic available in Logic Apps. Another key value prop of this service is that it provides many different connections with many services, allowing you to orchestrate all of these services along with functions, which you or someone else in your organization might have written. So all of these workflows are internally represented by a declarative format, JSON, as I mentioned. So that's very, very friendly with your existing CI/CD pipelines. One of the best parts about Logic Apps is the connectors. Logic Apps has over 200. It's incredible. And it goes without saying that all of these, most Azure services are supported here. But also from this list, you can see many popular third-party services like Dropbox, Twitter, Salesforce, and so on. And this all happens without requiring you to understand any of these other services. It completely abstracts the integration details of how to communicate with these other services or their specific APIs, SDKs, and protocols. And that's really powerful. So now, let's do a demo of Logic Apps. And I really like this demo because it's actually something I'm using, and it's really, really helpful to me. And I'm going to show you how I really, really easily made a Logic app that gets up and running to tell me what my commute is like every day. So here I am back in the Azure portal. I have here my Quatrazni test Logic app that I've built for you. As I mentioned, I'm using this actually right now to help my everyday life, which has actually had an impact on my life. So Logic Apps, even just in this simple example, is something that can help you as well. Also, for the record, this example that I'm going through is on the Logic Apps documentation, which walks through very easily how to get up and running with a Logic app, and will show you just what's happening and how to do everything that you'd need. So what this Logic app is doing is checking traffic on the way to work, and then storing it as a variable and sending me an email if necessary. So let's go and first see what's happening during this trigger. So this logic app is a timer-based trigger that is running every weekday at these intervals. Now, I didn't actually have to type in each of these. I typed in 15-minute interval between this period. So that was very easy to get up and running. Then the next part is using the Bing Maps API. I live in Capitol Hill in Seattle. I work in Advanta in Bellevue. So these are my 2 waypoints. And what I want is to figure out time with traffic in miles. The distance is miles, and I am driving to work. Now, the other cool part is that I can create a variable locally to do this custom manipulation of the data. If you hover over here, we can see that I am actually just dividing what I received in response from the Bing Maps API call by 60. So I know, based on the parameters of this API, that the response I will be given is a travel time in seconds. But that doesn't necessarily tell me exactly, like 1,000 seconds doesn't tell me anything right off the bat. So I've divided this by 60 so I can send it in an email in a more informative way. So if the travel time exceeds 15 minutes, send an email. And if false, do not send an email. So to prove to you that this is working, I'm going to run. So this is taking a second to provision. Because it's serverless, there are no resources sitting idle. This is just up and running right now, and it successfully checks the trigger and runs. We see those beautiful green arrows, and we have successfully sent an email. So let's actually bump out to my email, and from me, just now, 9:01 a.m., we have, that actually wasn't this one, sorry. Just now, 10:04 a.m., as you can see, those triggers are successfully executing. 10:04 a.m., my current travel time is 23 minutes. Now, because that wasn't up to date, I'm gonna do it once more, just to prove to you that this is actually running on the spot. Performing the action to run, let's watch that email come in. And there it is, 10:05 a.m., current travel time is 23 minutes. So that was incredibly easy. As you can see, I'm using this. It's really helpful. It tells me how many minutes my commute is, and it's very helpful. Now, what I've realized, though, is that, hey, my commute actually takes more than 15 minutes every single day. So sending me all that spam, all of those emails, isn't really necessary. So let's actually go into the Logic Apps code view. As I mentioned, this is all backed by JSON. This is all of my information just hooking up with the Bing Maps API, getting my variable. So this is very declarative, and it's got my waypoints. It's very, very simple to use, and if you know what you're doing, it's very powerful. So let's say I've decided I want to change this from 15 minutes to 25 minutes. So we just saw that my commute right now should be 22, 23 minutes-ish. So let's save this Logic app and actually run it. So up and running, and we should see that no email was sent. So it successfully checked the trigger, and it is running. We have our nice check marks. Expression returned false, so this was a no op. We did not need to send an email because my commute is, and no new email, just those two, because my commute is currently 23 minutes. So that's incredibly quick, incredibly fast. You get up and running very, very easily in a very robust way. Now, one other thing I want to highlight, Logic Apps has an amazing versioning story. You can roll back changes that you've made because, as you can imagine, this is a drag and drop interface. So what if you do something wrong? You don't want to lose all of your progress. So you can actually roll back to previous changes. You can add in custom connectors incredibly easily. If you go back to the designer view, it's as simple as clicking next step or adding an action for this if statement. And Logic Apps is just a very, very easy way to get all of your integration solutions up and running. So we already talked about how important events are in the context of serverless computing. Event Grid is a service which allows you to manage all of your events in a single place. And notice that multiple Azure services today publish their events into Event Grid, and these events can be routed to multiple destinations. We have functions, logic apps, and even other services, like automation and generic webhooks. You can also create your own custom events, which is really, really powerful. The rich set of publishers and consumers opens up many interesting scenarios for you to construct already, and many more are coming on their way. What I'd like to point out is that this is a many-to-many relationship. So you can have many functions executing off of a single event, or you can have one function executing off of many events. This solution allows you to really easily address very complicated eventing solutions, and is the easiest way to get up and running and have a really nice backbone to your serverless application. Next, Event Grid makes some really strong guarantees in terms of performance and scale. Event Grid has sub-second end-to-end latency in the 99th percentile, which is just about as close to real-time delivery as it gets. Also, Event Grid can route 10 million events per second, so just absolutely massive scale. And an intelligent logic to retry the event delivery if the first execution does not succeed. So all of these make Event Grid incredibly powerful, and I would encourage you to try it in your serverless applications. And next, let's see this in action. The best part about Event Grid demos are that inherently they're demos of all these different services working together, because you can't really have Event Grid without the events themselves coming from somewhere else. So let's go back to the Azure portal, and I will show you this sample application I have created. So I mentioned at the beginning of this presentation that I would show you app service at some point. So this is a really good example of how serverless can be used to augment existing applications that you've created maybe before you found out about serverless or your existing business processes. So I have this application here, an image resizer application. And this example, while it might initially seem a little random, it's actually something that we've seen a customer using in the real world, so it's actually a very important thing. And it's a really good example of things that you can accomplish very easily with functions and Event Grid. So this application here, I wrote this code based on this GitHub sample. It's very, very easy, and Azure Functions is completely open source, as are many of our examples. So this is right here, up and running. And the GitHub URL is right here if you want to try this on your own. Also, it's documented very well, as I've been saying. So this image resizer application, what happens is you drag and drop photos here, and it sends it to Azure Storage using an Azure function. So this application, let's say this application was up and running. This is in production, and you've decided, oh, I actually don't want to store all of that information. I want to store smaller versions of those images, thumbnails. So let's go through what's happening here. We go back to the Azure portal, and we have our storage backend. This storage is hooked up with that web page, which is live, and we've got our containers in storage here. We have two containers. One is the images with nothing in it, and thumbs. No blobs found. Blob means binary large object. It's just the dump of the image data. So let's actually prove that this is up and running. So what happens is the flow of control is I drop an image here. It plops it in Azure Storage in images. Event Grid detects a new image in this folder. It calls an Azure function, which I am showing here. I can show you in the portal as well. The Azure function is right here. But the code that's actually doing this is it has some resizing instructions. It gets some information about where to retrieve the photo from, and then actually builds a new image based on the instructions given to the image stream, and then uploads that image back up to storage. So that same function is here, and I wanted to show you it in the portal because what's interesting to note is that because this function was created in Visual Studio, this is grayed out. You have read-only permissions because in the portal you don't want to have people messing with your existing pipeline. So let's go back to the storage account and actually prove this. So I'm going to upload a photo. Let's go to Space Needle because I'm in Seattle, of course. So that is uploaded. It is dropping into blob storage, calling out to Event Grid, which calls the Azure function, generating the thumbnail, and there we see the Space Needle thumbnail right there. Now to prove to you that that's there, let's go back to the storage account and see here the images. And here we have, if we refresh, we've got this image here. And we go to our thumbnail, refresh that image here. So now, again, we can just delete this to show you just how easy it is to do. And let's refresh this live web page. No more thumbnail as we deleted it. So now that we've seen Azure Functions, Azure Event Grid, and Azure Logic Apps all in action, without any management of infrastructure, with very easy getting up and running scenarios, I'd like to show you some real-world examples of customers having success with serverless architectures. So I mentioned before that the image resizing example is not necessarily at face value the most useful example, but actually something we've seen customers have success with. So first, Fujifilm. Fujifilm has a very popular image management sharing service that handles more than 1 terabyte of data each day. So they were looking to improve the customer experience by providing better reliability and lower latency. And another goal was to re-architect their service in a way that allows them future enhancements more quickly and at a faster cadence. So in a previous version of their service, they found that they were spending an inordinate amount of time dealing with things that had nothing to do with their core business. Things like managing the infrastructure, worrying about adding more servers when demand goes up, and so on. So they moved to a serverless architecture, and they didn't have to do any of that. They saved 75% of their development costs. And when they started building the actual service, by virtue of using Azure Functions, they could very naturally adopt a microservices architecture, which decoupled the development efforts from different teams and allowed them to introduce enhancement to the system without disrupting the existing service. Now, this improved the uptime of their service and was just a really, really massive benefit for the company. Next, Quest. Quest is a really good example of a SaaS application that's built on top of serverless. So Quest built a solution to help their customers manage their Office 365 and Azure AD environments. And they built it as a SaaS solution entirely based on Azure serverless technologies like Functions, Cosmos DB, and Event Hub. As a result, they saw faster time to revenue and massive scale, in addition to the regular costs and effort benefits that I had mentioned before with Fujifilm. Now, Flexure is a really, really interesting story. Flexure builds solutions for retail companies. So they use IoT and machine learning to collect signals about user actions, and they use this data to help their customers fine-tune their marketing efforts. The interesting part is that they didn't only build a solution using Azure Functions, they built a solution to expose Azure Functions to their customers. So they found they were spending a ton of time developing custom capabilities for specific customers, and they thought that these customers would benefit from actually having the ability to write code. So they exposed to their users the ability to write code and then actually run that code through Azure Functions. So it's kind of like functions on top of functions. Anyway, they had a ton of regular benefits, in addition to the one great benefit that they spent a ton of time building custom functionality and now could just allow their customers to do it as well. So I would like to encourage you all to follow us on Twitter at Azure Functions. We are very active on Twitter, and if you have any questions or even just want to reach out and say hello to our really cool product team, I would encourage you to do that. Also, we have a blog that is our latest updates. I wrote a blog post in December. It was actually January, and it has many, many views, and it has encouraged a lot of really good conversation. And also, it's very easy to get started with Functions. You don't even need a credit card or an Azure account. You can just go to Try Functions and get started today. So thank you for taking the time. Again, I'm Colby. That's my Twitter handle if you want to reach out to me directly. And I hope you learned some really interesting information about serverless technology.